Good day everyone, my name is Janice De Los Santos. I am going to report the history of agriculture. Agriculture is the reason why people were able to build communities, cities, and civilizations. Without farming, humans would still be moving from place to place just to look for food. Origin of agriculture. Agriculture began independently in different parts of the globe and included a diverse range of taxa. At least 11 separate regions of the Old and New World were involved as independent centers of origin. The development of agriculture about 12,000 years ago changed the way humans live. They switched from nomadic hunter-gatherer lifestyles to permanent settlements and farmers. Agriculture started around 12,000 years ago. Before this, people depended only on hunting animals and gathering plants. This lifestyle was risky because food was not always available. When people discovered that seeds could grow into plants, they started planting crops. This allowed them to stay in one place and build permanent house. Farming started accidentally when people noticed plants growing from thrown seeds. This picture shows farming in ancient Egypt where animals were used to plow the land. This proves that people already knew how to use tools and animals to make farming easier. Animals like oxen help farmers prepare land pasture. They were the earliest form of farming technology. Around 9500 BCE, people in the Levant started growing crops instead of collecting wild plants. These crops included wheat, barley, peas, lentils, chickpeas, and flax. These crops became the main food source for early people and helped increase population. Wheat is one of the oldest foods still eaten today. Emmer wheat and incorn wheat were early types of wheat. They were easier to harvest and store compared to wild plants. Peas and barley were also important because they could grow in different weather conditions and last longer when stored. Lentils and butter peach provided protein for early farmers. Flax was used to make cloth, ropes, and oil. This shows that agriculture was not only for food but also for clothing and tools. 800 BCE evidence for cattle herding. People keep cattle around for easy access to food, including milk, blood, and meat, and for use as load bearers and plows. The Taurian Hapless B. taurus was probably domesticated somewhere in the Fertile Crescent about 8,000 years ago. People began keeping cattle near their homes for easy access to milk and meat. Cattle were also used to pull plows. In ancient times, cows were considered more valuable alive than dead because they helped farmers every day. 7000 BCE cultivation of barley. Animals are domesticated. Megar, one of the most important Neolithic 7000 BC to 3200 BC sites in archaeology, lies on the Kachif Plain of Balochistan, Pakistan and is one of the earliest sites with evidence of farming wheat and barley and herding cattle, sheep, and goats in South Asia. By 7000 BC, sowing and harvesting reached Mesopotamia and Dur, and the super fertile soil just north of the Persian Gulf. Sumerian ingenuity systematized and scaled it up. Farming spread to Megar and Mesopotamia. People learned to plant, harvest, and store crops properly. This period shows how agriculture supported growing communities. Megar is older than the pyramids of Egypt. Megar is an important archaeological site in Pakistan. It shows early evidence of wheat farming and animal domestication. The people of Megar also practiced storage and trade, which helped their society grow. Next is 6500 BCE cattle domestication in Turkey. Remains of domesticated cattle dating to 6500 BC have been found in Turkey and other sites in the Near East approach this age also. Some authorities date the domestication of cattle as early as 10,000 years ago, and others almost half that amount of time. Regardless of the time frame, it is generally accepted that the domestication of cattle, fowl, sheep, goats, and pigs and dogs. Remains of domesticated cattle were found in Turkey. This shows that animal domestication happened in many regions. Different communities learned from each other and improved farming practices over time. 6000 BCE, Indus Valley grows from wheat to cotton and sugar. Evidences of the presence of wheat and some legumes in the 6th millennium BC have been found in the Indus Valley by 3500 BC. Cotton growing and cotton textiles were quite advanced in the valley. By 3000 BC, farming of rice had started. Other monsoon crop of importance of the time was cane sugar. By 2500 BC, rice was an important component of the staple diet in Mohenjo-daro near the Arabian Sea. By this time, the Indians had large cities with well-stocked granaries. The Indus Valley people grew wheat, rice, cotton, and sugar cane. They also built granaries to store food for future use. Cotton farming in the India existed thousands of years before modern textile industries. Indus Valley art. This artwork shows daily life related to farming. It tells us that agriculture was central to their culture and economy. Art is important because it helps us understand how ancient people live. 5500 BCE, Sumerians start organized agriculture. By the Bronze Age, wild food contributed a nutritionally insignificant component to the usual diet. If the operative definition of agriculture includes large-scale intensive cultivation of land, monocropping, organized irrigation, and use of a specialized labor force, the title "inventors of agriculture" would fall to the Sumerians. The Sumerians were one of the earliest urban societies to emerge in the world in southern Mesopotamia, starting ca. 5500 BCE. The Sumerians developed organized agriculture. They used irrigation canals to control water flow. They were among the first to write farming records on clay tablets. 5400 BCE, archaeological proof for domestication of chicken. Chickens, Gallus domestics, were first domesticated from wolfram, called red jungle fowl, a bird that still runs wild in most of Southeast Asia. It was probably domesticated by about 8,000 years ago in what is now Thailand. However, recent research suggests there may have been multiple regions in distinct areas of South and Southeast Asia. Chickens were domesticated from the red jungle fowl in Southeast Asia. They later became an important food source. Chickens were first kept for rituals, not food. 5400 BCE, linear band ceramic culture in Europe. The linear band ceramic culture (LBK) is the name given by German ecologist F. Klafflich in 1884 to the first true farming communities in Central Europe, dated between 5400 and 4900 BC. The LBK people are considered the importers of agricultural products and methods, moving the first domesticated animals and plants from the Near East and Central Asia into Europe. The linear band ceramic culture introduced farming to Europe by bringing crops and animals from Asia. This helped Europe move from hunting to farming communities. 5000 BCE, Africa grows rice, sorghum. In China, rice and millet were domesticated by 8000 BC, followed by the beans mung, soy, and azuki. In the Sahel region of Africa, local rice and sorghum were domestic by 5000 BC. Local crops were domesticated independently in West Africa and possibly in New Guinea and Ethiopia. In China, rice and millet were domesticated. In Africa, sorghum and rice were grown. Rice can grow in flooded fields, which helps control weeds naturally. 4000 BCE, plops make an appearance in Mesopotamia. Circa 4000 BC, the plop variously flow is believed to have been invented by the Sumerians of Mesopotamia. Jethro Tull, the credit for having invented the seed drill, one has been found to be illustrated on a carved stone seal from Sumer. Though some hypothesize that domestication of the horse occurred as early as 4000 BC, in the Ukraine, the horse was definitely in use. By the Sumerians around 2000 BC, horse is domesticated in Ukraine. The invention of the plough changed farming. It made land preparation faster and easier. The plough is one of the most important inventions in human history. 3000 BCE, maize is domesticated in Americas. Maize was first domesticated probably from Teosinte in the Americas around 3000 to 2700 BC, though there is some archaeological evidence of a much older development. The potato, the tomato, the pepper, squash, several varieties of bean, and several other plants were also developed in the New World, as was quite extensive terracing of steppe hillsides in much of Andean South America. Agriculture was also independently developed on the island of New Guinea. In the Americas, maize or corn was domesticated. Crops like potatoes and beans were also grown. Corn cannot survive without human care. 3000 BCE, turmeric is harvested at Indus Valley. By 3000 BC, turmeric, cardamom, pepper, and mustard were harvested earlier in India. These spices later became valuable trade items. India became known as the land of spices. 2737 BCE tea is discovered. The Chinese have enjoyed tea for millennia. Scholars hail the brew as a cure for a variety of ailments. The nobility considered the consumption of good tea as a mark of their status, and the common people simply enjoyed its flavor. Tea was first discovered by the Chinese Emperor Xinong in 2737 BC. Tea was discovered in China and became part of daily life. Tea was discovered accidentally when leaves fell into boiling water. 2000 BCE, first windmill in Babylon. The first true windmill, a machine with vanes attached to an axis to produce circular motion, may have been built as early as 2000 BC in ancient Babylon. By the 10th century AD, windmills with wind-catching surfaces as long as 16 feet and as high as 30 feet were grinding grain in the area now known as Eastern Iran and Afghanistan. Long before electricity and modern machines, people already knew how to use nature to help them work. One good example is the windmill. As early as 2000 BCE, people in ancient Babylon may have built the first true windmill. This windmill had blades, also called vanes, attached to an axis. When the wind blew, the blades moved in a circular motion. This movement could be used to do work like grinding grain. During that time, grinding grain by hand was very tiring and slow. The windmill made this job easier because it used wind energy instead of human or animal power. Wind is free and always available, so it was a smart solution for early civilizations. By the 10th century AD, windmills became more advanced and were widely used in areas now known as Eastern Iran and Afghanistan. These windmills were very large, with wind-catching surfaces up to 16 feet long and 30 feet high. Because of their size, they could catch more wind and produce stronger power. 1000 BCE, sugar processing in India. Sugar cane originated in New Guinea, where it has been known since about 6000 BC. From about 1000 BC, its cultivation gradually spread along human migration routes to Southeast Asia and India, and east into the Pacific. It is thought to have hybridized with wild sugar canes of India and China. To produce the tin canes, it spread westwards to the Mediterranean Sea. Between 600 to 1480, sugarcane has a very long history of cultivation in the Indian subcontinent. Sugarcane is a plant that people have used for thousands of years. It originally came from New Guinea, where it has been known since about 6000 BCE. Over time, people moved it to other places. By around 1000 BCE, sugarcane was being grown in India and parts of Southeast Asia. As people planted sugarcane in India, it mixed or hybridized with local wild sugar canes in India and China. This produced new types of sugarcane, often called tin canes, which were easier to grow and process. People learned to extract juice from the cane and make it into sugar. This was an important discovery because sugar could be stored and used as sweetener, medicine, or even for trade. Sugar cane slowly spread westward over the centuries. By 600 to 1480, it had reached the Mediterranean region, where it became popular in Europe and in the Middle East. In India, sugarcane was not just a food crop, it was part of culture, trade, and daily life. The process of turning cane into sugar shows how early humans experimented with plants and created useful products. This long history of cultivation in India makes sugar cane of the oldest and most important crops in human history. 500 BCE raw cultivation in China. Scattered seed farming is the practice of throwing the seed onto the fields at random. By throwing the seed randomly, half the seed would not grow and make it impossible to weed the field. The Chinese, on the other hand, planted individual seeds in rows, thus reducing seed loss. The planting of crops in rows also allowed for intensive hoeing, which in turn reduced weeds. In early farming, people often used scatter and seed farming, throwing seeds randomly on the field. This caused many seeds to grow and made weeding very difficult. Around 500 BCE, the Chinese improved farming by planting seeds in row. Row cultivation reduced seed loss because each seed had space to grow. It also allowed farmers to use hoes more easily to remove weeds, which helped crops grow better. This method made farming more efficient and increased food production. By planting in rows, the Chinese showed how careful planning in agriculture could improve results and make farming more productive. Year 200, multi-tube seed drill invented in China. A seed drill is a tool used to plant seeds in the soil more efficiently. Before seed drills, farmers used broadcasting, which means scattering seeds by hand. This method wasted many seeds because they were unevenly spread and often didn't grow well, resulting in lower productivity. The first known attempts at seed drills were by the Sumerians around 1500 BCE, who used primitive single-tube drills, but this never spread to Europe. Later, in 200 CE, the Chinese invented the multi-tube seed drill, which allowed farmers to plant several rows of seeds at once. This innovation made planting faster, more precise, and less wasteful. Year 700, Arab Agriculture Revolution. During the Islamic Golden Age, 18th to 13th century, agriculture in the Middle East and North Africa changed greatly, known as the Arab Agricultural Revolution. Farmers introduced many new crops from different regions. From Africa, they brewed sorghum, from China, citrus fruits, and from India, crops like mangoes, rice, cotton, and sugarcane. These crops spread across Islamic lands where they had never been grown before. This exchange improved food variety, farming techniques, and trade. The revolution shows how sharing knowledge and plants between regions can transform agriculture, increase productivity, and influence societies for centuries. Year 1000, coffee originates in Arabia. Coffee began in Arabia around 1080, when roasted beans were brewed into a drink. With the 13th century, Muslims drank it regularly. Coffee helped the Dervishes stay awake during prayers and spread into everyday life. As Islam expanded, coffee traveled with it to new regions. Year 1492, Columbian Exchange changes agriculture. The Columbian Exchange started after 1492, linking the eastern and western hemispheres. It involved the exchange of plants, animals, foods, people, diseases, and ideas. New crops, livestock, and technologies spread worldwide, transforming agriculture, diets, and societies. This exchange had a lasting impact on global ecology and culture. Year 1599, First practical greenhouse. The first practical greenhouse idea existed in Roman times. Emperor Tiberius wanted cucumbers year-round. Roman gardeners used wood carts, moving plants in sunlight and indoors at night, storing them under frames called specularia covered with oiled cloth or mica. This early greenhouse allowed controlled growth of vegetables throughout this year. Year 1700, British Agricultural Revolution. The British Agricultural Revolution, 18th to 19th century, greatly increased farm productivity and retained, improved techniques and tools to produce more food, supported population growth, and feed workers for other jobs. This agricultural boom helped supply labor and resources that fueled the Industrial Revolution, changing society and the economy forever. Year 1700, Charles Townshend popularizes crop rotation. Charles Townshend promoted crop rotation, a system of planting different crops each season to maintain soil fertility. His methods increased farm yields and productivity during the British Agricultural Revolution, reducing fallow land and supporting population growth. This innovation made farming more efficient and influenced agriculture across Britain. Year 1837, John Dewey invents steel plough. In 1837, John Deere invented the first commercially successful steel plough. Its polished steel blade cut through tough Midwestern soil easily. Unlike previous plows, this innovation made planting faster, more efficient, and supported the expansion of agriculture in the United States, helping farmers produce more crops. Year 1860, high cultivation changes. By the 1860s, new mechanical hay cutting devices were developed, leading to modern mowers, crushers, windrowers, balers, and field machines. These tools made harvesting faster, reduced labor, and improved efficiency, transforming hay cultivation and supporting larger scale farming operations in the growing agricultural economy. Year 1866, Gregor Mendel and Mendelian inheritance. In 1866, Gregor Mendel explained how traits are passed from parents to children. By studying pea plants, he discovered patterns of inheritance. His work became the foundation of genetics, helping scientists understand heredity, plant breeding, and how characteristics are transferred from one generation to another. Year 1879, milking machine replaces hand milking. In 1879, Anna Baldwin patented one of the first milking machines in the United States. Her invention used a vacuum device connected to a hand pump. This machine replaced hand milking, saved labor, improved efficiency, and helped modernize dairy farming practices. Year 1892, first practical gasoline-powered tractor. In 1892, John Frawley built the first practical gasoline-powered tractor in Iowa. Unlike steam engines, it was lighter and easier to use. This invention improved plowing and farm work, marking an important step toward modern mechanized agriculture. Year 1900, birth of industrial agriculture. Around 1900, industrial agriculture began with the use of synthetic fertilizers and modern machinery. New farming methods, genetic technology, and large-scale production increased food output. This system now produces most supermarket meat, dairy, fruits, and vegetables worldwide. Year 1900, birth of industrial agriculture. Around 1900, industrial agriculture began with the use of synthetic fertilizers and modern machinery. New farming methods, genetic technology, and large-scale production increased food output. This system now produces most supermarket meat, dairy, fruits, and vegetables worldwide. Year 1930, first aerial photos of agriculture. In the 1930s, aerial photography was first used in agriculture. Governments used airplane photos to study soil, crops, and forests. This helped with soil conservation and land management and planning, laying the foundation for modern agricultural mapping and monitoring techniques. Year 1939, DOT becomes popular. In 1939, Paul Mueller discovered that DDT was a powerful insecticide. It quickly became widely used to control pests during the 1940s and 1950s. Synthetic pesticides were produced in large amounts, marking the beginning of the so-called pesticide era. Year 1944, Green Revolution begins in Mexico. The Green Revolution began in Mexico in the 1940s to increase food production. Scientists developed high-yield crops and better farming methods. These changes helped food production keep up with population growth, but also caused social and environmental impacts that are still discussed today. Year 1972, Organic movement takes root. In 1972, organic farming groups formed IFO-AM or IFOAM, the International Federation of Organic Agriculture Movements. The organic movement promotes farming without synthetic chemicals. Supporters believe organic agriculture is healthier, more sustainable, and better for the environment and future generations. Year 1996, commercial cultivation of genetically modified plants. In 1996, genetically modified GM plants were first grown commercially. These plants were designed to resist pests, tolerate herbicides, survive harsh conditions, and last longer after harvest. Crops resistant to herbicides and insects, like BT crops, quickly became widely used in agriculture. That's all. Thank you.